and welcome back to my channel Learn with Nikhil. So in our previous lecture, we have studied about forward kinematics. In this lecture, we'll see some examples on forward kinematics based upon the robots which we had studied earlier. So if you remember, in our previous lecture, we have studied this robot. We had find the DH parameters for this robot. Now in this lecture on Robo Analyzer software, I'll show you to find the DH parameters and see the matrix. So let's begin. So this is the robot which we had drawn on the Robo Analyzer software. We had studied all the parameters. These are the DH parameters we had studied: the joint offset, joint angle, link length, and the twist angle. These are the four parameters, the DH parameters. Now we'll see it using this software. We'll see the DH parameters, the matrix we'll see. First, just see, if I click on forward kinematics, this is the position or this is the movement. As the initial value and the final value both are same, so there is no movement. I'll change this to 180. Okay. So now the analysis is complete. Now the movement. So this is the movement. Practically it is not possible, the movement like this. You can change the initial and the final values and you can see the simulation of the robot. So initial value is 90 degree and the final value is just 100 degree. So some of the movement or just few movement of this robot is done. You can change the values according to you want. Now finding the matrix. For finding the matrix, you have to click on link configuration. So the DH parameters we had calculated. We had seen the coordinate transferring from this end, the base of the robot, till the end effector. We had seen the transformation. You can visualize the DH parameter. You can visualize it together, how it works. Clicking on together, you can see how it moves. Now this is just for the joint 1, traveling from joint 1 to the joint 2. You can visualize this entirely at once also. If you want to just see the joint 2 traveling from this end to the next joint. The rotation and everything. For the joint 3 also you can visualize together. From here to the end effector. So finally we have to see the coordinate, how it travels from the base to the end effector. And you can see totally directly from the base to the end effector also by clicking this. So it will travel and see all the parameters, how the rotation of the coordinate is there. You can totally visualize this. This part we had already seen earlier in a previous lecture. Now using this DH parameters, as you can see, this robot is a 3 degree of freedom robot. It has 3 degrees of freedom. It has 3 rotational joints. So according to the 3 rotational joints, as you can see, the z-axis is pointing in this direction, the z-axis is pointing in this. So they are rotating along the z-axis. So you have 3 rotations along the z-axis. So according to that, you can find the transformation matrix for all the links. Link 1 with respect to the base frame or the previous link frame. So link 1 with the previous transformation of link 1 with the previous frame or the base frame. So for the link 1, base frame and the previous frame is one and the same. I click on update. So this is the transformation matrix of link 1 with respect to the previous frame or the base frame. In this case will be one and the same. As for the joint 1 or the link 1, the previous and the base frame is same. So this is the first matrix. For the link 2, we can see the matrix with respect to the previous frame. For manual calculation, you have to do like this. So this is the link to with respect to the previous frame, the matrix, as it is again rotating along the z-axis. This is the rotation and this is the position matrix. And then last, link 3 with respect to the previous frame, update. So this is the final. This is again the rotation along the z-axis. So this is the rotation along the z-axis. So this is the link configuration. You can directly, finally you have to multiply all these 3 individual matrices manually. If you are calculating, you have to multiply these 3 matrices manually, and then you will get this final value, that will be link 3. That is nothing but the last end effector position with respect to the base frame. If I click on update, this is the entire matrix, this end effector with respect to the base frame. So multiplication of all the 3 matrices will give me this value. You can see this same matrix here also, the end effector configuration, where it gives the value of entire this with respect to the base. So end effector with respect to the base, this and this will be same, as this is the total. As finally we want the end effector configuration, that the position of the end effector with respect to the base. So this one example we have taken and studied earlier also. I'll take one more example which will make it clear. So this is the next example. This is the robot we had seen earlier. It has 2 rotary joints and 1 prismatic joint. So this is rotary and prismatic joint. Again you can see the z-axis. It is along prismatic joint, it is along the link, and this is rotating about the z-axis. So this is the DH parameters we had studied, how it came, I had shown you. Now we'll move to the Robo Analyzer software, where we'll study the matrix. So this is the robot which we had drawn. It has rotary joint and the prismatic joint. The DH parameters you can see 2 rotary or revolute joint and 1 prismatic joint. The joint offset, this is a fixed value for the rotary joint and it is variable for prismatic. Joint angle, it is variable for the revolute joints and it is fixed for the prismatic joint. You can change it here, then it will not get changed when you do the forward kinematics. The link length, twist angle. So these are the 4 DH parameters which we had studied. Here also you can visualize the DH parameters. You can visualize its single clicks, how it is done, the joint offset. I'll just show you an example. Now the joint offset is 0, so if you click it will not move. But if you make the joint angle, that is 0.2. So this is the joint offset. So now the coordinate is here, it has to move above. So if you click on joint offset, this is the length it will travel. But now we have taken an example of joint offset as 0. Now you can visualize it entirely together, all the links as we had done for our previous robot. This is from of the joint 1 of the link 1. So link 1 is between the first joint and the 0th joint. You can see them individually and you can see the base frame to end effector, directly from the base to the end effector. So this is, you can visualize. And next is the link configuration. So for the link configuration, this is the previous robot. So link 1 with respect to the previous link frame, update. So these are the values, the matrix for the homogeneous transformation matrix of link 1 with respect to the previous frame. So link 1 with respect to the previous frame. Likewise, you can calculate link 2 with respect to the previous frame, link 3 with respect to the previous frame. For the link 3, it is prismatic. So according to that, it has changed. Then finally, You can click on EE configuration, update, and this is the homogeneous transformation matrix of end effector with respect to the base. So according to this, you can entirely visualize how it works. You can see the position of the end effector. So this is how the robot moves. You can calculate each and every tip. So this was the start point. So these were values of the start point. Now for the end point, if I click on update, this is the matrix for the end. And you can find the matrix in between also. If I click here update, so these are the values where I clicked at the random position. You can set the values and you can check the matrix for each and every point also. So hope so this part is clear to all. This was all about the forward kinematics. Now with this, we will move to the inverse kinematics in our next lecture. Thank you for watching. Do subscribe. See you in the next lecture.